Hello, my name is Diana Fisher, and I am going to present a use of generative artificial intelligence, that is, large language models, and how it may support our efforts to develop system dynamics lesson plans to use in our classes. I am not an expert in the use of LLMs. I will show you what I have experimented with that have application for teachers wanting to use LLMs to infuse system dynamics modeling into their courses. There are some tests scientists use to find out how well artificial intelligence can solve difficult problems. In early 2024, ChatGPT 4.0 scored just 5% on the ARC-AGI assessment, but subsequent versions of ChatGPT scored 88% by December of the same year on the same test, years ahead of the assumed improvement target. Note, the LLM video in this course uses the free ChatGPT 4.0. There may be a newer free version of ChatGPT by the time you view this video. The concepts for using the newer version should be similar to and will be an improvement over ChatGPT 4.0. These AI videos will be updated as needed. Let's look at the agenda for this video. First, we have to prepare the LLM to understand system dynamics core concepts. I will show you a sequence of steps for high school algebra students 15 to 16 years of age, where the teacher wants the students to study the dynamics involved in the spread of an epidemic. I will next identify 7 hierarchical levels of systems thinking core concepts. I will show you how to have an LLM develop systems thinking and system dynamics assessment questions, followed by having an LLM produce targeted feedback interwoven within the student response of an open-ended question. Finally, I will have an LLM which is specially trained in system dynamics in Stella Online translate a given text description of a small intermediate level systems problem, produce a stock flow model which can be opened in the free web-based Stella Online system dynamics modeling software. The LLM that we will use in this demonstration will be the free version of ChatGPT 4.0. If you do not already have the free ChatGPT 4.0 app on your computer, please locate it and download it to your computer. ChatGPT 4.0 is created by OpenAI. Please note that the commercial version of LLMs are always more powerful and more accurate. Since we will be using only free versions of the LLMs we plan to demonstrate, make sure you always review LLM output for accuracy and appropriateness. Emory Gatepi wrote an excellent free book, Systems Thinking in Education, which focuses on the use of system dynamics tools and concepts for use in education. That book is available as a free download on the System Dynamics Society pre-college webpage at the URL shown on this page. Unfortunately, the full text of Gatepi's book is too large for the free LLMs to allow as an upload file. So I took a core 1/3 part of this book and stored it as 2 files you could upload into ChatGPT 4 to train it to understand some core system dynamics concepts. Please download these files using these URLs. LLMs can provide significant support in developing the sequence of activities that might be useful to consider when developing a lesson. Here is the prompt that I gave ChatGPT 4, asking it to produce a sequence of activities to help me, a high school teacher teaching an algebra class, design a lesson to help my students understand the dynamics involved in the spread of an epidemic. I told the LLM I understood system dynamics modeling, and I wanted my students to be able to build the stock flow model to capture the epidemic dynamics by the end of the sequence of activities. The LLM tells me what it is going to produce for me, summarizes some of the prompt information. It starts the first step, introducing epidemic dynamics in the sequence by telling me the objective for this step. It identifies the activity to use and then lists 3 questions I could ask the class at this point. This screen shows just the titles for steps 2, introducing behavior over time graphs, 3, introducing stocks and flows, 4, building a stock flow diagram, 5, exploring feedback, 6, experimenting with model variables, 7, policy and real-world reflection, which were broken into the same parts as step 1 on the previous slide. It also provides the description of a final project. The final note indicates some possible new prompt information you may want to give the LLM if what it has given you so far is not enough. Large language models can support our efforts to develop systems thinking and system dynamics assessment questions to use in our classes. These are the titles of the 7 hierarchical systems thinking and system dynamics concepts levels: reorganizing systems, representing systems with stocks and flows, identifying feedback, understanding nonlinear behavior, using conceptual models, creating simulation models, and testing policy by using stock flow structure. Within each category, we list behaviors we thought students should understand to demonstrate capability within each category. Those behaviors will not be shown here. This slide shows a list of variables the LLM produced for a 10th grade second-year algebra class that might be part of a scenario involving deer surviving in a forest that contains vegetation and predators. The students are to determine which variables represent stocks and which might represent flows for a stock flow model of this system. The LLM not only creates the list and describes the problem for the student, but provides a teacher answer key. This is a level B question. If students are given open-ended questions, LLMs can support teachers by providing either summative or targeted feedback to students. This is an extremely valuable time-saving tool for teachers to use. To provide an example of getting the LLM to provide feedback for an open-ended question, I first had to provide a scenario and a correct response for a sample open-ended question. I chose to teach the LLM the scenario involving the spread of an epidemic and in identifying the susceptible and infected population variable and giving it a stock flow model diagram as well as the graph of the susceptible and infected populations and becoming an infected flow. I explained the 2 feedbacks that were present and how the feedbacks and transfer of loop dominance determine the behavior shown in the graphs. The second part of the explanation is not shown here. In this slide, I will show the prompt that I gave the LLM using the correct answer for explaining the graphical output for the spread of an epidemic and using the student's incomplete response that was provided, produced targeted feedback to the student by highlighting student sentences that were not complete explanations, by providing comments in italics with square braces around it, recommending to the student what concepts were missing. Make the comments right after the sentence to which it applies. Give a title within the comment in bold, referring to the general idea that is missing. Be somewhat general in your feedback, selecting the 4 or 5 most important feedback comments to make to help them understand what is missing in their response, pointing the student to what is missing, but not telling the student exactly what to say to fix it. For the sake of this example, I created an incomplete student response for the LLM to work on to produce the feedback. The incomplete student response describes the shape of each graph, but does not use the feedback involved as part of the response. In this feedback that was provided to the hypothetical student from the LLM is shown here. The student sentence is in green and the LLM feedback in blue. When the student indicates that the susceptible graph drops quickly as more people get sick, the feedback given is to ask what causes this drop to speed up and then slow down. Consider how one loop becomes more dominant than the other over time. Now I will show a very exciting, hot off the presses method of having Stella with AI capabilities translate a text description of a systems problem into a stock flow model. To access the AI panel in the software, locate the 2-star button at the bottom of the Model Settings panel. This is for Stella Online, which is freely available to everyone. This is the assistant panel for building models. Make sure the mode is set to build. Create a title or brief description of the problem. Copy and paste background information into the panel if desired. Type in your prompt and view the AI reasoning that occurs when the prompt is analyzed. IC Systems, producers of the Stella System Dynamics modeling software, have added an additional very useful feature to their AI capability. They added a discuss mode that allows you to run an AI-generated model with loops that matters turned on, that is the feedback analysis tool assistant, and produce a table output and send that information back through AI to improve the model you previously built and explain in detail the reason the model behaves the way it does. You can choose the LLM you want to work with from the list provided. Create a title description of the new analysis you want. Include additional background information if desired. Provide additional output from the model run, that is like table output, in the behavior description section, and provide a new prompt for this cycle of analysis. This discuss feature will then produce more detailed reasoning for your model. This is an example of a very simple prompt asking the AI to create a stock flow model for a simple bank account that has 5% annual interest compounded monthly and $2,000 deposited monthly. The model appears in a format that needs to be reorganized, as is shown in the second diagram. The diagram is correct, as are the definitions, unit, link polarity, and documentation for each icon. This shows that the prompt and the resultant AI reasoning are stored within the model file. This slide shows the prompt asking the AI to extend the previous model by adding a savings account that grows at 10% interest per year and is fed by a deposit of 10% of the checking account balance per month. 5% of the savings balance is also to be transferred to a car account to save for a future purchase of a car. The model is shown here. It is correctly designed, except for the fact that the car account should have interest added, but none was specified. In the earlier experiments, the LLM did create an interest flow for the car account, one time making it 8% and another time making it 3% annually. So one needs to be careful in analyzing the LLM output to confirm that it meets the request given in the prompt and is also reasonable. One might think that getting LLMs to produce system dynamics models is a great boon to helping us understand systems, since the model helps to display the possible structure of a given system. But recall that Forrester said that the process of building the SD model is where the most learning occurs. Some problems with having LLMs build our system dynamics models. We may not understand why all the stocks that the LLM chooses to include should be included. Of course, we could ask the LLM to explain why the LLM thought they were needed. The model the LLM builds may be large, and it may be hard to understand the interconnections. Of course, we could ask the LLM to explain the interconnections. The equations that the LLM uses to define some of the components may be pretty sophisticated and not easily understood. This is a serious shortcoming, even if you can get the LLM to explain each equation. One value for most of us is that the equations used in our models are relatively simple and easy to understand and explain to others. We could start developing more acceptance thinking rather than creation thinking. Getting an LLM to build a model sidesteps the important thinking about what should be part of the model and how components should be connected. Building an SD model in stages allows the modeler control over why and how the model is constructed. Here are some recommendations that I would like to make. Use the SD model built by an LLM as a suggestion for how to get started. Have the LLM recommend stocks for the system's problem, or recommend feedback interactions that could be presented in the system's problem. Use a core part of the LLM model created and have students in 3-person groups sketch and test an additional concept that they want to add to the model. Use a collection of several articles on the same systemic problem and see what type of system dynamics model the LLM produces. Thank you for your interest in using AI to support infusing system dynamics into your courses.